All right, Mr. Van Dyke back in. Welcome back, math fans, to another pre-AP Pre-Calc 11 video. Here in this lesson, we are adding and subtracting radical expressions. So we did a whole bunch of simplifying and rules. Now we get to do something interesting with them. Let's take a look at this interesting and let's see how we learn to collect like terms. So we're going to make a note here on collecting like terms. So all this is going to like really come down to how well do we collect like terms and how well do we know it. And we get to collect like terms because of GCFs and distributive property. Well, what does that mean? Well, if I had 5x plus 3x, all of you are going to say right away, Mr. Van Dyke, you got 8x. Okay, yeah, sure. But how do you know I have 8x? Well, this has a GCF of x and x, right? So I have a GCF of x on each, and I'm going to take that GCF out, and then I have 5 plus 3, and that 5 plus 3 becomes x times 8. And really, I'm counting the same thing here, right? When I'm collecting like terms, I'm just seeing, hey, what am I counting many of the same thing of? So here, I can do the exact same thing with a radical of any sort of shape of radical, any sort of flavor of radical, and collect like terms with them. Well, what do you mean, Mr. Van Dyke? What I mean is this. If I had 5 root 3 plus 3 root 3, so let's say x is equal to root 3 here, I am going to say that this is actually 8 root 3. But how we get there is I took out a common factor of root 3, right? That's the GCF. I'm going to add 5 plus 3, right? That GCF came out as root 3, gets to go up front. And really what we have at the end of all this is 8 root 3, right? And it works because of the distributive property and because of collecting common factors like this. So let's see what simplifying this looks like in terms of other factors here. So let's try root 27 plus root 12 minus 8, and let's simplify as far as we can. Okay, 27, I'm just going to do this a bit more automatically than we did last lesson. So if you're not clear, go back to the last lesson, try it out. Pause the video, stop, and try it yourself till you get to the answer. But don't just go, I don't get it, so I'm not going to watch the rest of the video. If there's a step you don't get, go ahead, try it out till you do understand the step. Try it yourself. Call a friend. Pause the video. Ask me on Teams. Do what you need to do, but get to the point because I'm going to go a bit quickly now. So here I know that root of 27 simplifies to 3 root 3. This is going to simplify to 2 root 3, and this is going to simplify to 2 root 2, right? Because I have 9 and 3 here, that becomes 3. 4 and 3 here, that's 2 root 3, and this is 4 times 2. This is going to be 2 root 2 then. So as we do this, I can collect some like terms. Here's a like term. Here's a like term. This is an unlike term. So I got to collect it all together. So this is going to be root 3. 3 plus 2, and this is the only one I'm going to do this with, minus 2 root 2, but 3 plus 2 is actually 5. So my final answer here is going to be 5 root 3 minus 2 root 2. Since these are unlike root 3, root 2, I cannot do anything else with them. This is your solution there. That's as simple as it can get. Right, so I turned a couple of different radicals into 2 radicals, right? I moved it down, right? We took a big thing and made it smaller. So let's try this with some variables as well. Let's see what happens if we have variables. So let's take root 27 xy, so 27 xy, and we'll take the root, and we'll go plus 8 xy, and do that, plus 8xy, we'll do that, do that, do that, and let's just see what we get here. Well, this is going to be 3, and this will be 3xy, and this will be plus 2 root 2xy. I don't have a lot to work with here. These are different. I don't have anything. Unlike radicals, right? This radical is not the same as this radical, so I can't do anything with it. Like I could force something else, but it's not going to be nice and it's not going to be useful, so I'm not going to talk about it, right? If you see something there, that's good. More power to you. I'm not going to force something out of it. All right, let's try it. Negative 3 root 12 plus 4 root 75. Okay, 12 was 2 root 3, so I'm going to get negative 6 root 3 here. And 75 is going to be 25 times 3, so that's 5 times 3. So this is going to be 20 root 3. Good. Right, so I'm just kind of skipping that step. So be sure that if you're not getting that step, go back to the previous videos and learning. But math fans, here we go. Root 3, root 3. We took a big expression, 2 terms, and now it's becoming 1 term. It's being put together. Let's actually factor it. Root 3, negative 6 plus 20. And root 3. This becomes 14, math fans. And we get to 14 root 3. Air horn. Maybe I need an air horn beside me while I do this. All right, you got it. Good. Right, so we got it as 1 term, and nice and simple, and we can make simplifications that were not immediately present before. Love it. Okay, so 4 cube root 16, got this, 4 cube root 16, and we're going to add 3, and we're going to do cube root 54 right there. And now we just got cube roots, right? Same thing, same business. 8 and 2, 8's the perfect cube, so that comes out as 2. So I'll get 8 cube root 2 left over, plus, and then 54, that's 27 and 2. So 27 is my perfect cube, comes out as 3, so this is going to be plus 9. This is going to be cube root 2. And math fans, same radical on each. Look at that perfect union of 8 and 9. Adding together to 17 to get a cube root of 2 on the end. Wonderful. Love to see it. Okay, let's get a little more funky now. For the rest of these, let's assume x and y are greater than or equal to 0. And let's get funky with it. I promise funky, we're going to get funky. All right, 63. So this is going to be 3x, 63y, minus 5. 28 x squared y. All right, we are going to get funky with this. So what that means is, let's put this together. 63, 9, and 7. 7 doesn't work. 9's perfect square. 9 comes out as 3, so I'll get 9x. And this will be root 7y. Y doesn't have a buddy to escape with. 5, 4, and 7, so 4 comes out as 2. That's minus 10. X comes out, so that comes out as an x, and then root y and root 7y left over. Well, the radicals are exactly the same. Root 7y, and there's an x in front. So the only thing that's changing, right, the only thing that I'm subtracting is 9 and 10. So 9 minus 10 is negative 1. So all I need to write here is negative x root 7y. Look at that simplification. Like looking at the original statement, 3x root 63y minus 5 root 28 x squared y, you'd be like, there's no way that we can get this to be like play nice with us. But we did. We forced it. We made it play nice by using our radical rules. And now we're like, oh, this is why we want to do those radical rules, right? Like we're going to get some interesting things and we can make some nice things happen if we do the radical rules nicely. So this is going to be 20x squared y minus 2, 45, and we'll get still more practice on that simplification as well, y squared, okay? And if we look at this, 4 and 5, so that'll be 2, x, single x comes out, that'll stay, so I'm going to get 5y left over. All right, we're good. 45, 3 and 5, so 3 comes out. Oh wait, this is 3 cubed. So 3 comes out, so that's 6, and a y comes out. Since this is y squared times y1, a y squared comes out as a y. So what I have left over is a y stays behind and a 5 stays behind. But I have 2x minus 6y Not the greatest, do I? 2x root 5y minus 6y root 5y. What I'm going to do is I'm going to take a GCF of 2, and I have 2 from here as well, and a GCF of root 5y and leave the rest. So what I'm going to do is I'm just going to say this is going to be 2 and root 5y, and then what's left over is going to be x minus 3y, and that's it. So I'm taking a GCF of 2 root 5y out. So I do have another factor in here of x minus 3y, but maybe I can get rid of my radical nicely. If I have a linear thing and if I have radical, maybe later on with some more learning or some more doing, we can get rid of one of those things in future problems. All right, let's test this out with a little more than 3 now, or 2. So let's just get roaring for 1 or 2 more here, and then we're cooked and out. So root 32x plus root 42y minus 50x plus 27y. Okay. Let's cook it. This is a root, so 16 and 2. 16 is perfect square, so this is 4. 2x. 16 and 3. 16 is the perfect square, so this is going to be 4 root 3y. And this is 25 and 2. 5 is the perfect square, so this is going to be 5 root 2x. And 27, 9, and 3. 9 is the perfect square, so 3 comes out, so this is 3 root 3y. And so we're just going to collect the 2x's, and we're going to collect the 3y's, right? Because these are different common factors. So the 2x's, I have 4 minus 5, so I have negative root 2x. And I have 4 plus 3, so that I have 7 root 3y. I don't like having a negative go first. I never do. So I'm just going to rewrite it as 7 root 3y minus root 2x. Wonderful. Love to see it. Good. Okay. A little bit more. Last one. Promise, math fans. My mouth is like I'm a little parched here as well. But I will promise you this is the last one. So I'm just going to talk about what if I have fraction? What else is going on? Well, we're just going to make this the best darn mixed radical it can be. So 16 x to the 4th, y to the 5th. Right, so we're going to put that together. We're going to put that like that. Minus xy 54 xy squared. We're going to put it together like that. And I see, this is a cube root over here as well too. Everything looks nice and clean. Let's get everything out under those roots. Now I'm hunting for cubes. So 5 over 2 is going to stay. 8 and 2, that's going to come out as a 2. So this is going to be a 2 up top. X cubed and x to the 1. And a single x comes out. And a y comes out. And what is left behind in this first one? A 2 gets left behind, and an x gets left behind, and a y squared gets left behind. Okay, there's an xy here. 9 and 6. Well, oh wait, no, this is a cube, so this is 27 and 2. So a 3 comes out, and a 2 stays behind. So I'm going to multiply by a 3. And no x and y's can come out since I need I need a group of 3 for each. Nothing can happen there. So this is going to be cube of 2xy squared. Okay, good. That can cancel. So our next step here, we'll get 5xy, and this will be q2xy, 2xy squared under a cube root minus 3xy cube root of 2xy squared. All right, math fans. Last bit of business. This is a common factor. This is a common factor, right? Let me write my cube root symbol nice. I'm getting sloppy as time goes on. It's just because I think I'm kind of raring to go. I don't know why that's a 2. This should be a 3. Okay, right? But those are a common factor. X is first, then Y. And now you can see why order matters when I'm talking about common factors, right? And then I have a cube root with 2x, y squared, common factors. Now I'm just going to put it together. 5 minus 3, that's just 2. So I get 2xy, cube root of 2xy squared. Math fans, we have done it. We have solved math. No, we just solved this lesson. But I like to think we solved math. We did some, right? We made some significant progress. I hope you followed along in your textbook, in your workbook. I hope this was very enlightening. I have a wonderful class of scholars, and if you're hearing this again in another year, I hope you are also just as wonderful as this class that I'm recording the videos for. And if another class hears this and I'm not teaching at all, I hope this was of some help to you. With that, have a great day. This is Mr. Van Dyke signing off.